Bless him.
Hello, this is TecQuipment live Wednesday Q&A sessions. My name is Dion Knowles from TecQuipment, and I am joined today by two people. We are joined by Digital Dave, and we are also joined by our very special guest, who is Murat Islam. Murat, are you there?
I am here. Thank you very much, Dion.
Fantastic. Good to see you. Let me just mute this stream a second. We often have a slight battle of the desktops here. There we go. Don't you love a bit of background conflict? All right, so Murat. Murat is our special guest today, and Murat is going to be sharing his experience of engineering education over his time in Turkey, but also in the UK, talking about the importance of industry collaboration. You're going to be talking about a few other things as well, and specifically about real-world applications of materials testing and properties as well. Then we're going to come to Digital Dave, and Dave is going to be answering your technical questions during the session. First of all, I'd like to give a shout out to Semi. We've got Onmar from Bolton. We've got great to see you there. Semi is back. He watched us on Instagram, and he's back watching the YouTube live. This is live, and anything can happen. Hopefully all good stuff, and we might even get to see Dave's little puppy there as well. Now I've got a special guest today, and my special guest, I'm showing you quickly because I have to get it out of the way, is rabbit guest today. There we go. We have a second rabbit guest as well. Look at that. There we go. So that's me and my special furry guests done for today. Now Murat, let's go over to you.
I do have a guest, Dion.
Oh, we are really having the battle of the cuteness.
I will not go to my caravan and bring mine, no.
Look, he's going to sleep.
Oh,
he's going to sleep.
Very, very good.
Gorgeous.
Right.
Thank you, Dave. Let's get down to business.
Down to business.
Lots of people joining us online. Do let us know where you're watching from. We know we've got Semi in Turkey, but others, you've got lots of people there. Let us know who you are and where you are. That would be fantastic. Finally, Murat, on the edge of the galaxy there, as you are. Do tell us a bit about yourself. You came from a hazelnut farming background, I believe.
Yes.
That's a far reach from being a design engineer who you are today.
Yes, where I started wouldn't normally result in where I ended up. So I was probably quite lucky being here, to be honest. Like you mentioned, I'm from a farming family from a very small town. I sort of left that place about 5 years of age. Went to a bigger city, learned the civilization a bit better, I think, and did my normal primary school, secondary school, and high school education. And I was lucky to attend an Anatolian high school who gave me quite a significant amount of English background and science and mathematics background. That's where it actually really comes from. After finishing those studies, I went into a national exam that you don't have here. In Turkey, you have to go into a national exam and enter a university. And I managed to win the university that was in my hometown. I went back to Trabzon. That's where I am from Turkey, Trabzon. And it was called Karadeniz Technical University. Because it was a technical university, it had to have a lot of laboratory facilities, a lot of research going on. So it was really good for an engineering career. I was really pleased with that, and I really enjoyed my studies there. But my family sort of struggled a little bit towards the end of my studies too. So we ended up having some financial difficulties as a family. So once I graduated, I had to find a job straight away, and that didn't quite easily happen. I struggled finding a job. Even though my university and my background was good, I didn't have any industry connections. I didn't have any good references that actually sort of put out my name there and then tell me these good jobs are available. Why don't you apply for it? And I will refer you for it. Now, nobody like that ever was around me. So that was a bit of a struggle. My family sort of got into debt and sold everything in the place they lived in. They all went back to where we lived. So I had to figure out my way of life, really. My first idea was, okay, let's get out of this country, explore the abroad opportunities, gain the experience and come back to Turkey and study or work in Turkey after that. But it wasn't easy to find an internship abroad that would pay you. I couldn't find any opportunities, even in Turkey. I ended up managing to find a place to work for, and that was to do with residential gas pipelines. And it was a small job, but the company who hired me didn't actually pay my 2-month salary as well. So that wasn't a good job at all either. So it wasn't a great start for my career at all. It was only thanks to one of my friends again, I'm bringing it back to the contacts you have. One of my friends suggested to apply for a scholarship. I did it, he did it as well with me. He actually forced me to do it anyway, in the first place. He couldn't get it, but I ended up getting it. So I went to abroad and he stayed in Turkey and did other things in Turkey. He is teaching at a university now as an academic. He's doing well, so I'm not that worried about him. So life sort of throws at you different challenges at different times. You have to sort of work through them one by one. But engineering at the end pays off big time. Okay, I've been through difficulties, but as an engineer, I could come up here and present you this session. So you can see, it doesn't matter what background you are from, if you work at it, you will get to somewhere eventually. When it comes to industry connection, I lacked it in university studies as well. University had a lot of laboratory facilities and things available, but we didn't have any projects that we worked with an industrial partner. Everything we did was internal, or if our supervisors, our lecturers did something with a company, they would probably give us a little tiny thing to look at, but unless you are doing a master's or a PhD degree level, you don't get involved in proper industry relevant opportunities. In my days anyway, maybe it is slightly different now. It's been at least 10, 12 years now. So I had to find some references. I realized if I volunteered in the beginning, maybe with the institutions like the Chamber of Mechanical Engineers available in Turkey, and you have Institute of Mechanical Engineers here. If I got involved with them and volunteered for them, maybe organize events, got to know more people, have some industrial contacts who may have led me some different career now. But that didn't happen. So I ended up winning that scholarship, coming to the UK, doing a master's in mechanical engineering design, doing a lot of teamwork with the students, with the colleagues, and in the end graduate from that, continue to a PhD degree. And all these times I did have some struggles as well, mentally, not just financially. So I had to work through them. I still graduated with a merit, which was quite good for a student like me as an international student. I then continued to the PhD, but quit the PhD because I got married and I couldn't take my wife to the city I would have ended up going back to with the scholarship. So there were some challenges. I had to make serious decisions about my life. And took the risk and quit my PhD and started looking for a job, and straight away got a job, basically. It was not a problem at all. So the UK has many opportunities and they definitely need engineers, more engineers than ever before. And that demand is increasing as well. We need engineers and technicians that are qualified, that can support our manufacturing, support our development, our research. So we really need you guys to come along and join us and deliver really great solutions, great products for the whole society. I will stop there, Dion, if you have any other
Brilliant.
specific
Well,
questions.
that's really good. Such an interesting background. I just want to remind everybody that if they've got any questions for Murat and for Digital Dave, we will be talking in a few minutes, and do put them in the chat box. We've got lots of people who are letting us know that they're there, where they're from. We've got Andrew Macy at home in Hollingbourne. We've got Lee in Denbigh. We've got Semidaz Buluk. We've got Cabriso, lots and lots of people joining us. So it is awesome, awesome, awesome to see you all with us. Right, so Murat, you were talking about your experience of university in Turkey and then coming over to, I think you went to University of Manchester, was it?
Yes.
What do you think they could have improved? You've already talked about the need for industry collaboration, real world examples. Perhaps you could go into that a bit more and tell us how you think what things could be improved. It may be that many universities have already improved since your time there, but yeah, do share.
My experience sort of was that we had a really great technical background, so we learned the theory quite deeply. Okay, some of our lecturers maybe not as good at teaching as the others. We had that challenge. We had to put significant amount of study time in to learn certain stuff. We did some experiments, but they were sort of lacking in sort of quality and quantity. Let's put it that way, some of them especially. So I had to do my little own experiments at home to figure things out, understand them a bit better. If I'm working on fluid dynamics, get a cup of water and play with it, basically. What does it really do? If I'm thinking about a bending moment simulation, can get my ruler out and start bending it, put some different loads on it, see the deflection about it. So simple things, but that give you a perception, the perspective about how things really work, and can you really relate that knowledge to the actual theory? You see the real product, what it really does. Can you mathematically model it to represent what it really is doing? Then use that knowledge to apply somewhere else, doing a similar but maybe a different job. So repurpose your knowledge. So yeah, that was a bit lacking from the university. But in the end, you gain that experience through your workplace. So eventually you have to find the job that actually gives you those opportunities. Maybe take you to a manufacturing facility, maybe let you use a lathing machine or a CNC machine. Actually appreciate it firsthand rather than listening to someone or seeing it from someone. Once you get that little background, you appreciate how actually material really works and how it is really applied, and then think about how you can engineer it better to apply in a different application. Is that
brilliant? Fantastic answer. Tick, tick, tick. 100%. Fantastic, Murat. That's very helpful. Applying to the real world and getting your hands dirty, getting in there.
Definitely, hands-on is quite important for engineers, especially technicians, but definitely for engineers as well.
Yeah. Absolutely brilliant. Well, Murat, I'm going to give you a little bit of a break now. We're going to hop over to Digital Dave. There you are, Dave, in your home office.
Here I am.
Here you are. Welcome, Dave. How are you?
I'm good, thank you, Dion.
Good, good, good. Right. So, Dave, tomorrow we've got a webinar coming up on materials testing, which you'll be there. We've also got Kyle Hatchard, who'll be sharing some of that as well. And Murat will be coming back as well, because later on in this session, Murat's going to be talking a bit about materials testing and real life application, but he'll be talking more about that in tomorrow's webinar. Now, priming you a little bit for this and other people, I've got some questions around materials testing and properties. I want to talk about Young's modulus first.
Yeah. Go on
For
then.
those who are a little unfamiliar with the concept of Young's modulus, now some people we've got lots of engineers with us today, but there's a few that are not quite as well informed.
Yeah. Well,
can you give us a foundation there and
just a paragraph,
what kind of practical teaching equipment we might be looking at to illustrate Young's modulus and maybe Hooke's law as well?
Yeah. Let me tell you what I've picked up over the years, and this is my definition. But before I do that, I just want to share something with Murat. I heard last week what the definition of an engineer is. Okay, an engineer is a person that gets excited about things that no one else cares about.
Too right.
This is what Lorraine, my wife, found very amusing. But anyway, going back to Young's modulus, yeah, it's a mechanical property that measures the stiffness of a solid material. Okay, so it sort of defines the relationship between stress and strain in the material in the linear area of the graph, of the Hooke's law graph. That's my sort of interpretation of Young's modulus.
Right. And okay, so yeah, that's your interpretation of Young's modulus. How can we really illustrate this? Murat was talking about the need to really apply it to the real world.
Wow, yeah.
Well, and maybe Murat can give us some tips on little rulers and other, like maybe I've got a pen at hand, and how you might use a pen to illustrate Young's modulus. But that's only a rudimentary sense of understanding it. How can we understand it in more detail and take some real, do some real math behind it?
As far as our equipment, we look at Young's modulus on a number of applications in our range. We do tensile testing, so we look at Young's modulus there. We do torsional equipments, so we look at Young's modulus there. And then on our structured equipments, we look at a roof truss, and we look at the different members. Are they in compression? Are they in tension? We can calculate the Young's modulus just by looking at the gradient of the graph. So there's a number of equipments where Young's modulus flags up as a key word. And Murat is very keen on the study of couplers, and we use couplers. They're off-the-shelf couplers, but nonetheless they're couplers on our machines down on the MFP range. We use couplers to join the motor to the centrifugal pump, for example. So there has to be some flexibility, there has to be strength and longevity. It's got to last as well, especially in the real world. We want these things to last for a number of years. So although we use them in a wide variety of applications on our equipments.
Yeah, a number of years. I mean, when we look at some of the equipment, it goes back to the 1960s and it's still being used. Yeah, right, good. Okay, Dave, thank you very much for the insight into Young's modulus. Now I'm going to hop back over to Murat in the galaxy. Murat, let's talk a bit now about outreach. You've been heavily involved in the iMeche, the Institute of Mechanical Engineers in the UK.
Yes.
What really motivated you to get involved in the iMeche, and what does it really mean for you and for students, budding new engineers?
Institutional Mechanical Engineering is a professional body that represents whole our field of study. The most information I could probably get out of would be the people from the Institutional Mechanical Engineers. So I thought I best get involved with this institution, find people, ask them relevant questions and learn from them. And my main point was, first of all, get professionally registered as a chartered engineer. How do I do that? What do I need to be doing? How should I plan my career and my learning to actually achieve that chartered engineer status? But also, how do I make contacts and get references from different people, or at least learn new information from them so that I can apply it maybe in my industry, in my business. So share information, share engineering knowledge rather than specific confidential information. We just share the background of how maybe stress is calculated, how do we relate the tensile strength to the fatigue life, different properties that we can talk about and learn from each other. Networking is the main thing, but you mentioned outreach. Yes, we do a lot of outreach because we know the importance of reaching these young people, especially the young people, because but as they get older, they already made their decision. It's hard to convince them to change their mind. But early on, if you can convince them towards an engineering life, engineering career, or at least an engineering mindset, even though they are not engineers, it will give you a better chance that they will stay in the industry at least. and not move to different disciplines like medicine or like law. We would like to have qualified, highly technical engineers and technicians. We say engineers all the time, we emphasize on that all the time, but we do need technicians who actually apply the knowledge, who actually machine the things for us, who improve the processes of manufacturing for us. So we work as a team. We have to communicate with people. And how do we communicate as an engineer? How do we convince people with our ideas? Like all these different disciplines we need to be aware of.
Brilliant. In terms of role models, what kind of role models did you have through your youth that made you stick with it, get a passion for engineering initially, and then really stick with it and follow through?
My main inspiration was really Leonardo da Vinci. I was really inspired by the work of Nikola Tesla as well, but he is mainly electrical field. Although it's not that relevant to my field, I was impressed by the like crazy things he could think of. Imagination, creativity, that's what he had. And Leonardo da Vinci, in his day and age, produced thousands and thousands of inventions. And he didn't just produce the ideas, he produced art that supported it, that actually told the story, that made it infinite for everybody. Everybody wants to look at his drawings. It's not, we don't look at it as an engineering excellence, brilliance, we look at it as an art. But actually engineers do study every single intricate detail he pictured and learn from it and try to apply it as best as they can. And the best invention probably he came up, it was the application of golden number as a human body in a diagram. That is just phenomenal. There are many inspirational artwork you can see from him, but there are many, many other great engineers and inventors in the world to actually inspire from.
Did you have any real role models that you had contact with that were, personal acquaintances of yours that
yeah, I understand what you mean. Yes, in my childhood, I had two mechanical engineer uncles, but what did I learn from them as a mechanical engineer is very, very limited. I probably learned a lot more from my primary engineers than my uncles.
Right.
So I think it is good to be aware of the career, at least, even though you don't learn things from the person you know. At least you're aware of their career and their lifestyle and what they are doing. And maybe in some conversations you get to see, you hear certain things that will influence you. The real role model for me was actually from the Institutional Mechanical Engineers that I participated in. I'd like to name one person here. He's called Andrew Med, and he has been a great engineer. He has businesses, but he didn't stop there. He actually tried to give things back as much as he can. So he was a role model for me, a real role model as an engineer. I wanted to be sort of like him, not just be a technically expert person, but also give things back and bring more people into the industry and share the knowledge with people. So he really inspired me with that. But also other members of the committee I am part of. I learned a lot from them when it comes to communication, especially how we explain our ideas, how we sell our ideas, how we negotiate. All these things, I watched how they have done it, how they've applied it, and learned from them by just seeing them and discussing it with them. So if I didn't have that network, I wouldn't have developed these different soft skills. So you really need an additional part of people, committee of people, or a group of people that have the common goal, same goal, that you work together. If they are not helping you with your career, they may help you with your life, maybe give you some advice that will help you with certain things. So I think it's very, very important to network with people and increase your environment and horizon, really. Your perception needs to be expanded.
I totally agree. And you have to be challenged. Your viewpoints have to be challenged. You have to be willing to be challenged throughout your life. Murat, we had a really interesting question earlier on Instagram. Somebody asked about the transferable skills. What do you think are the most important transferable skills? And I think you touched on it in terms of negotiation a moment ago.
Yes, transferable skills for an engineer is your understanding of all mechanical material properties, all the application of engineering principles, the first principles, the hand calculations, Anything you get involved with like that is completely transferable. You can apply it to a different application, a different setting. But also the personal skill, your teamwork, how do you work with people? How do you put a document together? How do you structure your document? How do you present your information, like prepare presentations and talk to maybe a shop floor worker and the CEO at the same time or at different times? How do you make that difference of difference in the communication? How do you use your body language? All these things actually matter significantly, and you can take this knowledge anywhere.
Yeah, absolutely. Now I've got some questions here, and it's really great. Sambit, who's quite active on YouTube, Sambit has been volunteering his own aspirational role models, and I want to share those with you. And maybe you could share whether you agree with these. So Sambit said his role model is Stephen Timoshenko. Have you heard of
Timoshenko, we call him.
Yeah, sorry, apologies.
If you know about Timoshenko rules in the stress engineering world,
Right.
you will you will understand where he's coming from.
Right.
But there are
Okay.
many engineers came up with laws and rules that we apply in engineering, like Bernoulli, like Pascal, all these great people.
Yeah, and Sambit's mentioned Daniel Bernoulli, George Stevenson, and of course, Hero of Alexandria as well.
Okay.
So
There you go.
Yeah.
So he is interested in the history as well as the technical side of it, which is great, amazing.
Yeah, fantastic. In fact, we like to focus a bit on history at TecQuipment. Every now and again, when it's a birthday of an old academic, we will do a blog post that celebrates their life, talks about how they contributed to engineering.
Excellent.
So if anybody is interested in the history, then have a look at our blog, because we've got lots of different blog posts on the likes of Bernoulli, Thomas Young. I hope I got the first name right there, but I think it was Thomas Young of Young's Modulus. Okay, I want to shout out to Burkan as well, and lots of other people who've joined us online. I have a feeling you might know Burkan.
Yes.
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 Great. Okay.
We are on a WhatsApp group right now. I hope they are not pestering me.
Oh, no. Mute. Let him focus. Okay, well, you can go to your WhatsApp group for a second if you want, because I'm going to hop over to Dave now.
Okay.
So Dave, you're there, brilliant. Dave, now I would like to talk about, Sambit's asked a question. Let me see. Haha, Sambit likes to test you, Dave. I like this. Is applied mechanics and engineering mechanics both the same or different? And perhaps this is both of you could look at this one. Your perspective.
I don't know, not in my capacity, Dion. I'm the installation and training.
Okay, fair enough.
And commissioning manager. I get told what to install. Applied mechanics and what was the other?
Where we go back. Applied mechanics and engineering mechanics. But maybe Murat, what's your perspective on that as a design engineer?
I think you need to look at the description of the words themselves. What does applying mean? What does engineering really mean? Engineering is about making an improvement, making a change, understanding the boundaries of the conditions we are setting out. But applying is fitting it into those boundaries. So use that engineering knowledge and apply it into some conditions and make sure it doesn't go outside the boundaries the engineers actually set out. So that's the difference from applied and engineered, I believe.
Yeah.
Brilliant.
So Murat, when you were doing your homemade fluid mechanics testing on your kitchen table, did you do Archimedes' principle by any chance?
I play with a lot of stuff, like putting the cups upside down with water and taking the paper off and everything. How does the Bernoulli actually work this out? It's amazing. So yeah, I did play with things a lot.
Yeah, splendid.
Great. Right. Dave, I'd now like to come back to you with a technical question now. Somebody recently asked this question. It may even have been somebody who's joining us here today about the forced vibrations apparatus. Let me just show this to everybody. Now, there's a dampening part of this, and I'm just trying to get it up on the screen. There we go. And can you get that dampener separate, or do you have to buy it as part of the apparatus? And perhaps you could tell us what a little bit about this apparatus and what
well,
that
that's
dampening element does.
on the TM 1016. We have a solid beam, and we have two conditions. We have a free vibrations where it's basically like a cantilever, effectively like a diving board, and then we have forced, where the beam is fixed both ends. We have an out of balance disc on a motor that causes vibration. We are then able to calculate the natural frequency of the beam, but then for extra value to the experiment, we can damp the beam as well. So we have a small little reservoir of oil. A little plunger is attached to the beam, and we introduce damping into the beam, and that's included with the TM 1016.
Right. Brilliant. Okay, thank you for that, Dave. Right, I'm going to hop back over to Murat now. Murat, you touched on it earlier that, yes, it's not been the easiest journey for you from Hazelnut Farmer through to the outskirts of Manchester in Lancashire. And that often, when you have a tough time, comes with its mental health challenges. What would you perhaps you could share some of your experiences and tips of how you think, a bit of perspective, I suppose, for people who may also be struggling themselves. And also it's quite good for people who don't really understand mental health problems to get an appreciation for it, so that they can understand people who have those challenges.
Yeah. The good news I want to start with is you can come out of mental health problems. And once you come out of them, you will be a lot more resilient, a lot more stronger as well. Because you will realize certain things actually to be able to come out of it. And those things you learned will change your life pretty much. It is to do with understanding your state of mind, but your physical appearance. How do your chemicals in your body actually react when you see something, when you feel or hear something? How do you really physically react to it? And that physical reaction does have a relationship to your mental status as well, what your thoughts are. When you have a mental issue, you tend to think about negative things all the time. You tend to take things in the wrong way all the time. You get aggressive sometimes. And my symptoms were pretty similar. As I stressed, I ended up being aggressive. I ended up ignoring things or not hearing things properly, not paying attention. And then I made myself understand, am I angry right now? Right now, am I literally angry? And if I'm angry, what was the reason for it? And is it really, really a significant reason? So what you do is you step out of your own body, you literally come out of yourself, sit next to yourself, look at yourself and see what you literally just say what you see. So you explain yourself, you describe yourself. That means you are aware of what your status is. And same thing with the mental health. If you have a bad thought, why did it come there? Why do you think about the bad things? And then you start understanding this, first of all, then you start changing those to good things. If I ever come to think of something bad, can I just ignore that altogether, start thinking something good? So visualize yourself that you have actually succeeded. You have actually passed that deadline, and you already look at yourself that you actually hold the trophy. Already you are holding it, visualize it. Imagination is an amazing thing. It changes everything in your body. Your endorphin levels sky high. So, all your body changes to what you are thinking. So you need to control that, obviously. You need to manage that. My mental struggles was maybe caused by the financial difficulties I had. Okay, I came abroad as well, separated from all my friends, all my family, left all my country behind, on my own, make a new life here. It wasn't easy. I had to work hard. I had to do my studies as well as work part-time or temporary jobs while studying. So it was a constant study, like constant tension on my body. And I realized if I didn't exercise enough for a week, I went into a much higher stress level. So I started playing football all the time. I tried to run a little bit. I tried to do different things. When I went into the industry, things changed again. I didn't have enough time to do things. My exercise levels dropped again. And I didn't realize it. I didn't realize what I was going through. And the stress levels increased. The jobs sometimes obviously can be stressful. or they are not stressful, but you get yourself stressed out for no reason. And understanding that and overcoming that is a challenge, but you need to tell what you are feeling to other people as well, not just talk to yourself. You need to share your experiences, how you are feeling with others, get them to give you a different perspective, different idea about yourselves, and maybe some advice. I mean, how can they help you go through it? Have they ever been through something like this? And believe me, almost everybody have been through some mental struggles. There is no one in the world, I don't think, been through like none of the struggles. They would definitely have some problem in the past. Even the richest people, even the poorest people, we all are people. We all have challenges, struggles. And at some point in our lives, we struggled, but we did go through it. We passed it. So don't feel like there is no solution. This is the end. It is never the end. You will always find help if you seek for it.
Murat, I think it's so refreshing that somebody like you is willing to talk openly about it, because you're right, we all have struggles, and it can be really tough when you start out your career and you're bombarded with so many things, and you're finding your way of how to conduct yourself, how to communicate with people, how to manage expectations and meet expectations, and you need to talk to your managers and you need to talk to people around you so that they know what's going on in your head as well and they can adapt. And so you can learn from their experiences too, because it's tough. I mean, we all go through really tough times. We go throughout our life and peaks and troughs in our career. So great, thank you so much for sharing and thinking about being positive and focusing on that really great end goal during those negative wake up in the middle of the night moments of irrationality and stuff like that. So which I'm sure we all have moments like that, or maybe I'm just generalizing.
No, I agree.
Okay, right. Thank you, Murat. I'm going to hop back over to Dave now. Oh, Amira, I just want to mention somebody on here is wanting to say that it seems you like Manchester United. You were doing lots of dreaming at university.
I suppose. I used to play a football game when I was a child on the first computer, Windows 98 computer, and the only thing was playing Manchester United in a UEFA Champions League. Maybe that was the first clue that I would have ended up in Manchester anyway.
Yeah, brilliant. Good. Right, I am going to give you a break now, Murat. Dave, you are there ready and waiting for questions now. Dave, materials testing, creep testing now. I want to talk about creep testing. Where does creep testing apply in the real world, and at what point in a syllabus might you want to look at creep testing?
That sits right in our materials testing range. So the SM 1006, we are able to stretch, if you like, a variety of specimens. So that can be lead specimen, polythene, nylon, and we apply a small load to this specimen. And over time, and it can take some time on some of the tests, we are able to see the three sections of the creep. We see the primary, secondary, and then we see the tertiary shaped graph. And with VDAS, we're able to leave that test overnight if needed, and we can plot basically a load over extension graph. So it's fundamental to a materials testing course. It's a bit like tensile, but it's slightly different subject matter.
If you were to select a handful of pieces of equipment for understanding the basics of materials testing, off the top of your head, what would you go for?
Well, I want to look at stress. I want to look at strain. And then I'd look at all the different loading types on a material. So that can be an actual stress, an actual force, be it compressive or like say, or tensile. I'd then be thinking of a shear force test. I'll be looking at a bending moment test, and then I'll be looking at a torsional test, Dion, and all of our equipments would cover that. So we've got the SM1001 for torsion, STR 2 and 3 for shear force, bending moment, and SM1000 for tensile test. So they're the subject areas I recognise, and we're able to do product placement against those subject areas.
Brilliant. Thank you, Dave. Just reminding everybody who's watching this live, you can ask your questions in the comment box. Now I'm just checking to see, have we got anything for continuum mechanics, Dave? This is another one from Sambit.
Continuum?
Yeah.
No.
No.
Again, just a quick Google search would help me understand the definition of that, but it's not something, it's not a keyword that I understand
No,
or
it
heard of.
didn't ring any bells with me, to be honest. I mean, I'm no engineer. I'm familiar with the TecQuipment product base, but okay, great. So I'm going to leave it there with you, Dave. I think we're probably wrapped up with you, Dave, but we've got some more questions for Murat now. Murat, I'd like to talk about, we've mentioned materials testing here, and I mentioned that we've got a webinar coming up tomorrow. But for those not able to join the webinar and with us today, perhaps could you talk a bit more about how you use material testing in the real world and how you use all, lots of various parts of engineering discipline theory in your real world applications? I can pull up the pictures on this one as well.
If you want to bring them up, that would be good, actually.
Let's have this one here. Let's go for it. Pictures.
So to start with, I need to explain people what a coupling is, what it really does. I suppose Dave also mentioned coupling is sort of looks like what you see on the screen on the top left-hand side. It is literally a shaft that is connecting two different machinery together. And these shafts obviously spinning and rotating under significant amount of torque. So you have torsion, you have twist in the parts. And you want to control and limit the amount of twist in the material because you don't want much deflection. And you want to make sure when you put that much torque through the material, it doesn't actually snap and break. And the failure mode can be a ductile failure or a brittle failure, depending on the materials you selected, how hard the material is, what sort of strength the material has. So all these different things actually come into play. The Young's modulus you mentioned, that is literally just measuring the relative displacement to the relative stress levels. That's what it is, just the ratio of the two. So if I if I pulled a piece and it gave me only 1 millimeter deflection for 1 Newton force, if I pulled it 2 millimeter, will it give me 2 Newton, basically? Is there a linear relationship? And that linear relationship sort of defines early on what the Young's modulus is. And we have to understand that very well. We have to understand the yield strength. If the material is actually deforming and showing like on the right-hand side, top-hand side simulation, there is a bolt here that's under significant torque and shear load, and we are bending this bolt. It's under preload, it's under tension, so it is stretched. So everything you see purple and red are danger, basically. I don't want to see that. So I need to limit my load to bring that back to some green levels or yellow levels at least. So there are engineering around the materials this way. You need to understand the plasticity, not just the elasticity of the material. You tighten a bolt, you don't realize, but all the bolt threads are actually yielded already when you tightened it. And how much of it is really acceptable? Is it really acceptable for your application? When you say yielding, it means the metal is actually almost flowing. So imagine a metal behaving like a liquid and stopping there in the end, making like a solid again. Just visualize it somehow. So that is sort of the things we need to work with in the plasticity region. And we have buckling, how membranes that we have in the couplings. These are very, very thin materials, literally like a membrane that are disc shaped, and you twist them. And as you twist them, they sort of go into a buckling mode, buckling shape. How do you limit this? How do you control this? There are different applications. I mean, the pictures I sent you were actually all animations. So you could actually
were
see
they? Okay,
they were
sorry
animations originally. No, I sent you the pictures only this time. But if you could see one of my other videos, maybe, then you will get to see actual things moving about. But understanding of the material is crucial to designing anything. So this is a good one, actually, good one. Thanks for sharing this one. This is a coupling that I actually tested myself. I have an arrangement that puts torque through the coupling, only pure torque. There is no axial force, there is no shear force. It literally just put pure torque through my coupling. Then I measure what sort of stresses I get on the surface of my tube. Then I can be revalidated based on my simulations, based on my hand calculations, and verify that all the materials we selected, all the design we selected are actually correct and accurate. We verify the stress through that. And we measure the deflection as well. There is an arm, actually, the red piece standing on the disc is actually a long arm that's about a meter, meter and a half long. And it actually measures what sort of angle do you get when you twist this coupling, when you put torque through the coupling. So we measure torque to displacement, then it will give you a stiffness that's not Young's modulus, but a torsional stiffness, and relate that to the vibration of the system. If your system will vibrate or not. I need to understand what's the torsional stiffness of my coupling is. So yes, we need to understand the materials really well, and appreciating, like, using those, your equipment, actually, the equipment you provide to universities, I think is a brilliant way to get the first-hand knowledge of where those things are, how do you actually calculate them, how do you actually measure them, what do they really relate to in the physical world. So I do appreciate what you guys are doing, really. So it's great. It's great.
Good. Well, I really appreciate hearing how all of those different elements of engineering, particularly materials testing, we also touched on vibrations there as well, and which is within our theory of machines range. And yeah, it's so interesting to actually see it applied in the real world and a real life application, how you actually apply all of those elements in your day-to-day work.
At the end, this is a test work. This is like a simulation of the real world application. So the coupling may be sold to a massive large generator or a turbine. So this is real, physical, but still not the real thing in the world, the real application. Just to clarify.
Okay. So you then scale it up for your end of world, the real application. Okay, brilliant. That's fantastic. Thank you so much, Murat. I'm just reminding everybody who's watching this live, you can ask your questions to both Murat and Dave there. Everybody's in their home office waiting a few more minutes with us in this live Q&A to answer any questions you might have. Murat, where you came from, you had special bread there, is that right? Because I watched your webinar on last Friday.
Okay.
And I was thinking I should perhaps get into making some more bread.
Yeah.
What have you got any bread recipes for us?
I couldn't share it even if I knew it.
Is that a family secret? Don't.
To be honest, our family actually don't produce that bread at all, but it is very famous across to Turkey.
Oh, okay.
It is. Imagine a bread as big as your television.
Oh,
so
wow.
So like, you know, this is the bread. You see a semi-sphere kind of shape, maybe a bit less than that. And this thing actually lasts about a week going fresh, no problem at all.
Wow.
Sometimes. So it is a completely different taste, completely different texture to it than anything you find in the UK. I think you should go to Turkey, maybe Vakfıkebir, and try it yourselves.
Okay, fantastic. Good. We're getting the odd comical question through here. I think we'll leave the officer sausage question for everyone else to answer in the chat afterwards. All right, good. Well, thank you very much for all of your questions. Thank you for joining us, Murat. It's been a real pleasure. And Dave, thank you again for being back with us. Well, a quick reminder that Murat, Dave, myself and Kyle Hatchard are back on YouTube tomorrow at 1 o'clock BST. So that's an hour before this session started tomorrow. And we'll be going through all this materials testing, and Murat will be talking about this again, but perhaps in some more detail there as well. So do join us then for that session. But that's it from us today. Just checking back at the questions. We are done. Thank you so much for everybody for joining us all around the world. It's been a great pleasure, and we look forward to seeing you again next time.
Thank you very much, Dion.
Okay, bye now.
Thanks,
Dave.
Thanks, then. Bye, Murat.
Bye.
Bye.